All right, let's talk about something that so many of us in IT deal with every single day, that sprawling, chaotic environment where it feels like nobody has the full picture. Today, we're going to dive into how a philosophy called architecture as code, brought to life by a framework called Danica, can actually transform that chaos into a clear, evolved system.
So let's kick things off with a comparison you were probably not expecting. Microbial mats. Yeah, you heard that right. Those slimy, layered organisms that were one of the earliest forms of life. I mean, they were incredibly successful for billions of years, but they had one huge flaw. They just couldn't evolve to handle any real complexity. The source material for this draws this really powerful parallel to modern enterprise IT, and honestly, it's the perfect place for us to start. And this slide just lays it all out perfectly. On the left, you've got that microbial mat state. Sound familiar? Knowledge is trapped in a few people's heads. You know, that tribal knowledge. Processes are messy, and innovation just gets stuck. But on the right, that's where we all want to be, an evolved system. A place with a shared, holistic view and clear principles that actually drive innovation. The big question, of course, is how in the world do you get from the left side to the right?
Well, the bridge to get there is this philosophy called architecture as code. It's an approach that's designed to methodically take all that complexity and give you clarity and control over your systems. So, let's break that down. First up, architecture. Now, we're using the formal definition here from TOGAF, which is a super common framework in enterprise architecture. The key thing to grab onto here is that it's not just about drawing some diagrams. It's the fundamental blueprint of your entire system. The components, how they relate to each other, and the rules that guide how it all changes over time. Now for the as code part. And honestly, this is where the magic really happens. It means we start treating our architectural descriptions exactly like we treat software. We write them in plain text, we check them into version control systems like Git, and we use them to build a complete holistic model. It becomes a living, breathing asset, not some static document that's just rotting away on a shared drive somewhere. A philosophy is great and all, but you need a practical way to actually put it into action. And that's where Danica comes into the picture. It's a framework that was designed specifically to bring this architecture as code approach to life. At its heart, Danica is all about bridging this critical gap, the very one that keeps us stuck in that microbial mat state. Its whole mission is to capture complex knowledge from humans, through diagrams, notes, conversations, and structure it in a way that both other people and machines, including AI, can understand and work with. So what makes it different? Well, it's built on this really powerful core idea. Shape your tools instead of somebody else's tools shaping you. So instead of one giant, inflexible program, it uses a bunch of small, focused tools. It's all about highly structured data. And maybe most important, it has a really low barrier to entry. You can start small, for free, right on your own laptop. And this framework is just packed with powerful capabilities. It can read and generate diagrams from tools you probably already use, like Drawio. It can build complex data models. It can generate entire websites and command line tools. It integrates with AI, visualizes data in 2D and 3D. It can even track how it's being used. It's a really comprehensive tool. Okay, so that's the theory and the tool. But what does this look like in the real world? How do you actually put this into practice day to day? Well, the process flows in a really logical way. First, you capture the key concepts of your system in what's called a metamodel. You can think of it like creating a custom dictionary just for your business. From that foundation, you can automatically generate documentation. Then you start pulling in real data from all over the place: diagrams, config files, live info from your systems. This builds up that rich, holistic model, which you can then share with everyone through a website, an API, or even by generating brand new, up-to-date diagrams. So the crucial point here is this. You're taking all these separate pieces of information, the knowledge stuck in people's heads, the data from your actual systems, the diagrams that try to explain it all, and you're unifying them into a single interconnected model. One source of truth that's always evolving. Now, this all sounds technically pretty impressive, but let's connect it back to the real world. Why does this actually matter? What's the real payoff for you and your business?
Ultimately, it all comes down to wasted time and wasted money. I mean, companies spend millions of dollars and countless hours just onboarding new engineers, on those marathon troubleshooting calls, and on generic certifications that don't even teach their specific way of doing things. This whole approach is designed to tackle that waste head on. And here are the really concrete use cases. Imagine just radically cutting down your onboarding time because the architecture is clearly documented. or ending those marathon troubleshooting calls with 200 people on them because you can immediately see who owns a system. It's invaluable for partnerships where there's no shared history or for hackathons where you have to get productive like right now. It even helps you document your specific way of using complex cloud platforms.
You know, it all comes back to this one simple but really profound idea. A lack of clear documentation isn't just some minor inconvenience. It's the direct cause of chaos and stagnation. It's the very thing that keeps your organization stuck in that microbial mat state, unable to truly evolve. So I want to leave you with this question. What if your architectural diagrams weren't just static pictures anymore? What if they were live executable models that were always in sync with reality? What kind of new possibilities would that unlock for your team? What could you build then?